Hello. In this video, we're going to go ahead and look at continuity. So we want to look at continuity at some value of x equals c. So a function f is continuous at x equals some constant c if the following three conditions are satisfied. The first condition is that f of c is defined. In other words, the function is defined at that value. The second one is that the limit as x approaches that value exists. In other words, if so the first one is that the function is defined. The second one is that the limit exists. And this third one here is that the limit is the same as the function value. So for basically that last one really is the important one. But if the function value has to exist, the limit has to exist, and the function value has to be the same as the limit. That's that third one. So really the reason A and B are there is because that's the only way for the limit to equal the function value. Okay, so if f is not continuous at c, it is discontinuous there. Fantastic. Here's the thing though, we don't want to just look at continuity in terms of just a single point. We want to look at continuity in terms of intervals. So on a closed interval, so a function is continuous on a closed interval a to b if it is continuous on the open interval a to b. In other words, this includes the endpoints, this excludes the endpoints. B says it is continuous from the right at x equals a, and it is continuous from the left at x equals b. So here's an example of this over here. So what we have is this would be considered A, this would be considered B. Notice that this is continuous the entire way. You can just draw this without picking your pen up. And if this is A, we're getting close to A from the right-hand side, but not from the left-hand side because we're not going over there. So that's why we have to continuous from the right at x equals A. That's what's happening there. Continuous from the left at x equals B is what's happening here. And there you go. So this would be continuous on the entire interval a to b. Now this right here is an example of showing discontinuities. So right here, notice that technically the function does not exist. We want to go through this in order. So this would be the first thing you check for, the second thing you check for, and the third thing you check for. So for that first thing, we check to see if the function is defined at this value. Notice that at this value there's a vertical asymptote, and vertical asymptotes mean that the function is undefined there. So because of that first condition here, whatever value that would be means that this is not continuous at that value. Everywhere else to the left of it, it is continuous, because if you're looking at this point here, notice that the function is defined here. The limit is there, the limit is there, so the limit exists, and it's the same thing as the function value. Over here, notice that there's a discontinuity right here again because we have the function being undefined there. And then right down here, notice that that's actually still continuous here because the function or the function value is defined here, the limit is existing, and if you notice, the limit does equal the function value. Same thing here, except we can only do this on a one-sided limit here. So this would be it's continuous from the left going towards that point there. Alrighty. Well, there you go. This is a quick introduction to continuity, and we will go ahead and work with this in a second. I'll see you there. Have fun.